Hello guys, before we start let me introduce myself. I am a professional big data trainer and working in big data industry for last 8 years. Teaching is my hobby, that's why I created these videos. In my training program, first I work on theory part, then work on practicals. My each training program contains at least 100 to 150 practicals coding examples and at least one industry project. They also work on interview questions after completing of the subject. So before making any delay, let's start today's topic. So in my previous video, I discussed about the feature of Spark. I hope you guys have gone through that. So what are the benefits of Spark over MapReduce? So due to the availability of in-memory processing, Spark implements the processing around 10 to 100 times faster than MapReduce, whereas MapReduce makes use of persistent storage for any of the data processing. What does it mean? Spark uses RAM for storing the intermediate data, that's why it is 100 times faster than MapReduce. But if Spark use the same storage, like if Spark works on the persistent storage as well, then it is 10 times faster than MapReduce. So anyhow, Spark is faster than MapReduce even if Spark uses the persistent storage. Spark has a strong core which works as a building blocks for all the high level features like Spark SQL, Stream, Machine Learning, GraphX, etc. Let me show you an image. So what I'm trying to say is, in this diagram you can see that I have an Spark core, and with this and over Spark core works like a building blocks, and all the features like Spark SQL, Spark Streaming, Machine Learning, and GraphX are designed over it. So core is nothing but the part of Spark framework which contains API for RDD creation and RDD transformation. We'll discuss about the RDD later. So everything is designed on top of the RDD. So if any optimization is added into Spark core, added into the RDD, then it will automatically be the part of higher level features like SQL and all. So everything is designed over this core. So if you are adding anything in this core, that will automatically be the part of all the high level features, right? So this is the power of Spark. Okay, so Hadoop is highly disk dependent, whereas Spark promotes caching and in-memory data storage. Spark is capable of performing computations multiple times on the same data set. This is called iterative computation, while there is no iterative computing implemented by Hadoop. So iterative process means you can compute any value once and can use in multiple iteration within the application. So an iterative process it maintains the state for a particular variable. It does not compute it again and again, like we use the for loop and while loop in our daily use in Java. Spark tries to store things in memory, whereas MapReduce involves more reading and writing from disk. So you can see this is the example of iterative process, right? It is an example of iterative process. So in this image you can see for each MapReduce jobs, which is divided into multiple mapper and reducer, data is written from HDFS. Data is read from HDFS file, and multiple mappers are processing this data, and they are writing intermediate data into either in the distributed cache or on the disk. On the disk. So distributed cache is also a disk. It is a separate topic, so we will cover this later. I have already covered this in Hadoop and Yarn tutorials. Okay, and reducer reads the data from this disk and passing the output to another jobs. So this is an example of multiple jobs in which multiple jobs are running on each iteration. So tasks are reading the data from HDFS. So this is the mapper only job. So mapper are reading the data from HDFS, they are writing data to the disk, and in another iteration for next job, mappers are reading the data from disk and performing its transformation and writing it to the disk, and finally on the disk on the HDFS. So this is the example of iterative processing. So if we do the similar thing in Spark, then the things will be very fast. Okay. Now, sometimes people ask one question that disk is more fault tolerant than RAM. So does it means that Spark is less fault tolerant than MapReduce? So answer is no. I have already explained this in my previous video, but we will cover this in more detail in future videos. So what I have told that Spark provides two labels fault tolerance. It gets the one label from the HDFS and second label it's RDD. RDD is resilient distributed dataset, which is nothing but a fault tolerant data set. So please note one thing that Spark tries to store. So as I have already discussed that everything is tried to store in the memory and cache. So cache is nothing but memory. So please note one thing that Spark tries to store most of the thing in memory. So Spark application will always be memory intensive. So when you will be writing a Spark application and you want to have a great performance, then you are supposed to provide a good amount of physical memory to the application, right? So guys, that was from today's topic. Please do write your suggestion and comments in the comment section, and please do not to forget to subscribe my channel for getting the latest updated videos. Please click on bell icon for subscription. Keep watching and thanks for watching.